Deep in the heart of traditional manufacturing districts, where ancient craftsmanship meets modern sustainability, lies a factory where discarded copper wire transforms into magnificent cooking vessels. This is the incredible journey from waste to culinary art, a process refined over generations. Every day, tons of discarded electrical copper wire arrive at this facility. Remnants from demolished buildings, outdated electrical systems, and industrial waste destined for landfills. The recycling process begins with meticulous sorting. Different grades of copper require different treatment methods to ensure the highest quality final product. Experienced inspectors evaluate each batch, identifying pure copper wire from copper-plated alternatives and determining the optimal recycling pathway. Modern stripping machines make quick work of removing insulation, a task that once took hours of manual labor now completed in seconds with perfect precision. Despite mechanization, human expertise remains irreplaceable. Workers identify subtle differences invisible to sensors, oxidation levels, alloy content, and contamination. Copper's distinctive appearance has made it precious throughout human history. Antibacterial, highly conductive, and incredibly malleable. The sorted wire moves to massive industrial shredders capable of processing several tons per hour, reducing everything to uniform granules. Inside, rotating hammers spinning at thousands of RPMs pulverize the wire. The violence of this process is carefully controlled to prevent oxidation and contamination. What emerges is remarkable: perfectly sized copper granules, each piece maintaining the material's integrity while maximizing surface area for the next crucial stage. Advanced pneumatic systems separate materials by density. Pure copper follows one path while remaining plastic fragments and lighter metals take another. Powerful magnetic separators extract any ferrous metal contamination, ensuring the copper's purity reaches industry-leading standards of 99.9%. Quality control checkpoints throughout the process ensure consistency. Granule size must fall within tight tolerances for optimal melting characteristics. Now begins the transformation. In furnaces reaching temperatures of 1,100 degrees Celsius, solid copper granules become liquid metal, a process humanity has practiced for over 7,000 years. Traditional coal-fired furnaces still produce superior results according to master craftsmen. The gradual, even heating prevents oxidation and maintains copper's malleability. As the copper reaches its melting point of 1085 degrees C, a transformation occurs. The molecular structure shifts, and individual granules merge into a unified molten mass. Experienced furnace masters judge copper's readiness not by instruments, but by color, fluidity, and surface behavior. Knowledge passed through generations of metalworkers. Impurities rise naturally to the surface. Workers skim off this slag continuously, each pass increasing the copper's purity and ensuring the final cookware will have optimal thermal properties. When temperature and purity reach perfection, the copper is ready for casting. This moment demands absolute precision. Timing, temperature, and technique must align perfectly. Molten copper flows like luminous honey, filling molds with the raw material that will become cooking vessels. The temperature remains critical. Too hot, and the copper oxidizes. Too cool, and it won't fill intricate mold details. In this factory, hundreds of ingots are cast daily. Each will become raw material for traditional pot-making techniques refined over centuries. Cooling happens gradually over hours. Rapid cooling would create internal stresses and brittleness, while controlled cooling allows copper's crystalline structure to form perfectly. Each ingot weighs approximately 25 kilograms, dense, pure copper ready for the next transformation. Inspection occurs at every stage. Flawed ingots are immediately returned to the furnace for remelting. Only perfect ingots proceed to become cookware. Traditional pot making begins with power hammering. The ingot must be flattened and shaped into a rough disc, the foundation of every vessel. Copper must be repeatedly reheated during shaping. Unlike steel, copper work hardens quickly, becoming brittle if forced while cold. Heat restores its malleability. Master craftsmen can shape copper through feel and sound alone. Each hammer strike is calculated. Too hard creates cracks, too soft fails to move the metal. Modern spinning lathes accelerate what once took hours of hand hammering. The copper disc rotates while hardened steel tools gradually form the pot's basic shape. The spinning process thins the copper to precise specifications. For large cooking pots, walls typically measure 2–3 millimeters, thick enough for durability, thin enough for optimal heat distribution. In this factory, traditional and modern techniques coexist harmoniously. Machines provide consistent power, while human expertise guides every artistic decision. Planishing, the process of smoothing hammered copper, requires patience and precision. Thousands of small hammer strikes gradually eliminate imperfections while maintaining structural integrity. Rims must be perfectly circular and uniformly thick. Cutting lathes trim excess material while ensuring the pot sits level and stable during cooking. Stake anvils, specialized forms matching desired pot curves, allow craftsmen to hammer from inside while supporting the exterior shape. This technique dates back millennia. Handles undergo separate forging. Thick copper rods are heated, twisted for grip and aesthetics, then precisely shaped to match the pot's proportions and weight distribution. Handles attach through brazing, a process using copper-based filler metal that melts at lower temperature than the pot itself. Done correctly, the joint becomes stronger than the surrounding metal. The finishing workshop transforms rough copper forms into gleaming cookware. Each pot passes through multiple craftsmen, each adding their expertise to the final product. Polishing begins with coarse abrasives, removing oxidation and tool marks, progressing through finer compounds until the copper achieves mirror-like brilliance. Final buffing uses soft cotton wheels and jeweler's rouge, a compound containing iron oxide particles so fine they polish at the microscopic level. Interior surfaces receive equal attention to exteriors. Every surface a cook might touch or see must meet the same exacting standards. The finished surface quality rivals precious metalwork. This brilliant finish is not merely aesthetic. Polished copper develops better cooking patina and provides superior sanitation. Many pots receive decorative engraving, traditional patterns passed through generations. These marks identify the craftsman and celebrate cultural heritage. Some copper pots receive tin lining, a traditional technique creating a non-reactive cooking surface while maintaining copper's superior heat distribution properties. Before any pot reaches customers, rigorous testing ensures perfection. Visual inspection identifies the slightest surface flaws, while functional testing confirms structural integrity. Leak testing seems simple, but reveals critical information. Any water seepage indicates microscopic cracks or insufficient brazing, automatic grounds for rejection. Experienced inspectors can hear defects. Quality copper produces a clear, bell-like ring when struck. Any dullness or irregularity suggests internal problems invisible to the eye. Thickness consistency affects cooking performance dramatically. Inspectors measure at dozens of points, ensuring specifications are met within tolerances of 0.1 millimeters. Final aesthetic inspection ensures every pot meets exhibition standards. These vessels are functional art. They must perform flawlessly and present beautifully. Approved pots receive careful packaging. Each represents hundreds of hours of collective expertise, from recycling specialists to furnace masters to finishing craftsmen. From discarded wire to culinary masterpiece, this factory processes over 50 tons of recycled copper monthly, creating thousands of traditional cooking vessels. These giant copper pots will serve in commercial kitchens, restaurants, and homes across continents, each one a testament to sustainable manufacturing and traditional craftsmanship. From waste to wonder, from recycled wire to culinary heritage, the circle continues.